Let R be a relation on Z cross Z defined by A comma B related to C comma D. Means R is a relation given which is defined on Z cross Z, that is A to Z cross Z to Z cross Z. Say this is A where Z is integers. So in Z cross Z contains ordered pairs A comma B, let us take, and it is related to the other ordered pair C comma D. So it is given R is equal to A comma B is related to C comma D such that AD minus BC is divisible by 5. Divisible by 5 means it should be divided with 5. So 5 into some constant k, where k is some integer. So we need to check this R is reflexive, symmetric or transitive. So reflexive, the definition of reflexive, for every element in the set A comma A must belongs to the R. So for every element in this set A comma B must be related with A comma B. So let us assume or consider A comma B belongs to Z cross Z such that A comma B is related to A comma B. So which implies AB minus AD minus BC. So here A into B minus B into A. We can write AB minus BA, that is AB minus AB, which is equal to 0, is always divisible by, we can say is always divisible by 5. Hence we can conclude that the relation R is reflexive, because for every element A comma B, A comma B is related to A comma B because it is divisible by 0. Now for symmetric, coming to symmetric, symmetric definition says that if here in this case, if A comma B is related to C comma D, then C comma D must be related to A comma B. Basically the definition is, if A is related to B, then B must be related to A. So here in this case A comma B is related to C comma D, then we have to prove that C comma D must be related to A comma B. So let us consider A comma B is related to C comma D. So as per the definition, AD minus BC must be divisible by 5. That is AD minus BC is equal to some 5 into some constant k. So which implies we can also write BC minus AD is also equals to some negative 5 times of k. That is BC minus AD is equal to 5 into some negative constant, which we can say that BC minus AD is also divisible by 5. So we can also write this as C comma D is related to A comma B. So that CB minus AD, we can write CB minus AD is equal to 5 into some constant k. So for A comma B related to C comma D, we got C comma D is related to A comma B, and hence we can say that the relation R is symmetric. And now coming to transitive, transitive definition says that if A comma B, B comma C belongs to R, then A comma C must belongs to the relation R, and hence we can say the relation is transitive. So here let us consider, let us take an example because this is not transitive. We need to give one counter example. Let 4 comma 1 is related to 15 comma 5. So which implies that, so 4 5s are 20 minus 1 15s are 15. So 20 minus 15 is 5 is divisible by 5. So we can consider 4 comma 1 is related to 15 comma 5. And now let us take the second ordered pair. 15 comma 5 is related to 1 comma 1. So here we can say 15 ones are 15 minus 5 ones are 5. So 15 minus 5 is 10. Again it is divisible by 5. So we can say that 4 comma 1 related to 15 comma 5 and 15 comma 5 is related to 1 comma 1. Now we need to check that A and C. So let us consider here 4 comma 1 and 1 comma 1. So consider 4 comma 1 related to 1 comma 1. So which implies here 4 into 1, 4 minus 1 into 1 is 1. 4 minus 3, 4 minus 1 is 3, which is not divisible by, which is not divisible by 5. And hence we can say that for A is related to B and B is related to C, but A is not related to C. So here we can say 4 comma 5, sorry 4 comma 1 is not related to 1 comma 1, and hence we can say that the relation R is not transitive. So this relation is reflexive and symmetric but not transitive. So we can go with an option reflexive and symmetric but not transitive, second option. Let A be a square matrix such that A into A transpose is equal to I, then half times A times of A plus A transpose whole square plus A minus A transpose whole square simplification. Let us consider half into A into A plus A transpose whole square plus A minus A transpose whole square. 1 by 2 into A into, let us do A plus B whole square, A square plus A transpose whole square plus A into A transpose plus A transpose into A plus again here A minus A transpose we can write since we have the properties. A plus B whole square is equal to, when A and B are matrices, we can write A square plus B square plus AB plus BA. Similarly, A minus B whole square is A square plus B square minus AB minus BA. So here A minus A transpose whole square we can write it as A square plus A transpose whole square minus A into A transpose and again minus A transpose into A. And it is given A into A transpose is equal to I. So which also implies that A transpose into A is also equals to I. Because when two matrices A and A into B is equal to identity matrix, we can say A and B are in multiplicate inverse to each other. So A transpose into A also will give the same value. So let us substitute here half into A square plus A square, that is 2A square, and A transpose whole square plus A transpose whole square, that is 2 times of A transpose whole square, and here A transpose A and A transpose A gets cancelled, and A into A transpose A into A transpose also gets cancelled. So we can write 1 by 2 into A into, you can take 2 common, A square plus A transpose whole square. So that is A times of, or A into A square plus A into A transpose whole square. That is A into A square plus, we can write A into A transpose into A transpose. A into A square is A power 3 and A into A transpose is I into A transpose, which is equal to A power 3 plus identity matrix into A transpose will be give identity matrix into any matrix is always the same matrix A. So we can write A transpose. So A power 3 plus A transpose is the answer. So which is option D. Let vector A, vector B and vector C be three non-zero vectors. So we can consider vector A, vector B and vector C, all the three are non-zero vectors and such that B and C are non-collinear. So we cannot express B vector as some constant times of vector C, or in case the linear combination is given k1 times vector B plus k2 times of vector C is equal to 0 vector. So which implies that k1 and k2 must be equals to 0. So this is a condition for non-collinearity, and also given that if 5 a times a vector plus 5 times of vector B is equal to is collinear with lambda C, is collinear with vector C, so we can add some lambda times of vector C, and B plus 6 times of vector C, that is vector B plus 6 times of vector C is collinear with, let us assume, mu times of vector A, and then all A vector plus alpha times of B vector plus beta times of C vector is a 0 vector. Then what is the value of alpha plus beta? So here we can write, let us eliminate A. So from the second equation, in the first equation we can write vector A is equal to lambda times of vector C minus 5 times of vector B, and in the second equation vector A is equal to 6 upon mu times of vector C and plus 1 upon mu times of vector B. So from this both we can write lambda is equal to, lambda is equal to 6 upon mu and minus 5 is equal to 1 upon mu. So which implies mu is equal to minus 1 by 5, or 1 upon mu is minus 5, so lambda is equal to 6 into minus 5, which is minus 30. So lambda value is minus 30 and mu value is minus 1 by 5. Now consider vector A plus alpha times of vector B plus beta times of vector C is equal to vector 0. So A vector we can write any one of them, so lambda I can consider. So lambda times of vector C minus 5 times of vector B and again plus alpha times of vector B plus beta times of vector C is equal to 0 vector, and lambda value is minus 30, so I can write minus 30 times of vector C plus beta times of vector C plus alpha times of vector B minus 5 times of vector B is equal to 0 vector. So that vector C times we can write minus 30 plus beta, and again here alpha minus 5 times of vector B is equal to vector 0. So since B and C are non-collinear, so it is compulsory that minus 30 plus B must be equal to 0, that is beta minus 30 is equal to 0 and alpha minus 5 must be equal to 0. So we can say beta is equal to 30 and alpha is equal to 5. Therefore, alpha plus beta value is 5 plus 30, which is equal to 35. So I can go with an option B. Let PQR be a triangle with R is the vertex, minus 1 comma 4 comma 2, and M is the midpoint of the line segment PQ. So we can consider M is the midpoint. So 2 comma 1 comma 2, and the distance of centroid of triangle from the point of intersection of two lines. So we know that centroid is the point of concurrence of the medians. The line segment joining from vertex to the midpoint of its opposite side is called the median. Say RM is the median, and the centroid divides the median in the ratio 2:1 from the vertex. So we can say R is a point -1 comma 4 comma 2, and M is another point 2 comma 1 comma 2, and G is the centroid which is dividing 2:1 from R. So we can get the centroid by using the section formula as 2 times of x2, that is mx2. We have the formula mx2 plus nx1 upon m plus n. Similarly y coordinates. So we can write 2 times of 2 plus 1 times of -1 divided by 1 plus 2 plus 1 comma, and again 2 times of 1 plus 1 times of 4 divided by 2 plus 1, 2 times of 2 plus 1 times of 2 divided by 2 plus 1. So we can get the centroid as 4 minus 1, 3 upon 3, 2 plus 4, 6 upon 3, 4 plus 2, 6 upon 3, which is equal to G 1 comma 2 comma 2. So 1 comma 2 comma 2 is the centroid of the given triangle. Let's find the point of intersection of two lines. X minus 2 upon 0 is equal to y upon 2 is equal to z plus 3 upon minus 1, say is equal to lambda, and x minus 1 upon 1 is equal to y plus 3 upon minus 3 is equal to z plus 1 upon 1 is equal to say mu. So here we can write the x coordinate as 0 into lambda. Here we can x minus 2 upon 0 is equal to lambda. We get x is equal to 0 into lambda plus 2, so 2, and y is equal to 2 lambda, and z is equal to minus lambda from here, minus lambda minus 3, and similarly from the other line we can write x is equal to mu plus 1, and y is equal to minus 3 mu minus 3, and z is equal to mu minus 1. So that for the point of intersection, x coordinates and y coordinates, z coordinates of both the lines must be same. So for point of intersection, so equating the coordinates respectively, so we get, so here 2 and mu plus 1, so mu plus 1 is equal to 2, which implies mu is equal to 1, and the next one 2 lambda is equal to minus 3 mu minus 3. So when mu is equal to 1, we can substitute 2 lambda is equal to minus 3 into 1 minus 3, that is minus 6. So lambda is equal to minus 3. So we got the value mu is equal to 1 and lambda is equal to minus 3. Substituting any one of the value in any one of this line equation, we get the coordinates point of intersection. The point of intersection is x is equal to 2, y is equal to 2 into minus 3, and z coordinate is equal to minus of minus 3 minus 3. So that is x is equal to 2, y is equal to minus 6, and z is equal to 0. So the 2 comma minus 6 comma 0 is the point of intersection of the line. Let us consider to be, say this is M, and now we need to find the distance of the centroid to the point of intersection. So centroid is, we have the centroid is 1 comma 2 comma 2, and the distance between these 2 points, say mg is equal to under root of x2 minus x1 whole square that is 2 minus 1 whole square plus minus 6 minus 2 whole square plus 0 minus 2 whole square, which is equal to root of 2 minus 1 square is 1, minus 6 minus 2 minus 8 whole square is 64, and minus 2 whole square is 4. So which is equal to root of 69. So root 69 is the answer. So we can go with an option D, option 4. If in a GP of 64 terms, the sum of all the terms is 7 times the sum of the odd terms of the GP, then find the common ratio. Let the GP be geometric progression be, we can write AR, AR square, AR power 3, and so on, AR to the power, total 64 terms are there. So it will come up to 63 because A first term is A. So that the sum of all the terms A plus AR plus AR square plus and so on, AR to the power 63 is equal to 7 times the sum of the odd terms. Here odd terms we can consider AR square, the next number AR power 4 and so on. So we can write here A plus AR square plus AR power 4 and so on. Since the power of R is getting even, so we can write the last one is AR to the power 62. So we can say that clearly it is also geometric progression with the first term is equal to A and common ratio is equal to R square. So here also first term is equal to A and common ratio is equal to R. So we know that sum to n terms in GP is A into R power n minus 1 divided by R minus 1, where R is not equals to 1. So here we can write sum to n terms in GP is A into R to the power of, so total how many terms are there? 1 to 63 and again 164 terms are there. R power 64 minus 1 divided by R minus 1 is equal to 7 times, and here we can say first term is A and R square to the power of total. So 2 ones are 2 twos are 4 and so on, 231 times. So 31 plus 132 terms are there. So R to the power R square whole power 32 minus 1 divided by R square minus 1. So we can cancel here A, and R power 64 minus 1 divided by R minus 1 is equal to 7 times of, here R square whole power 34 is again R power 64 minus 1 divided by R square minus 1, we can write R minus 1 into R plus 1. So we may cancel here R power 64 minus 1 on both the sides, and R minus 1 is also cancelled where R is not equals to 1. So finally we can say that R plus 1 is equal to 7. So R is equal to 7 minus 1, which is 6. So we can go with an option. The common ratio of the geometric progression is 6, which is option 2. Suppose f of x is equal to 2 power x plus 2 power minus x into tan x into root of tan inverse of x square minus x plus 1 upon 7x square plus 3x plus 1 whole power 3. Then find the value of f dash of 0. We know that f dash of a is equal to limit h tends to a f of h minus f of a divided by h minus a. So here a is equal to 0, that is f dash of 0 is equal to limit h tends to 0 f of h minus f of 0 divided by h. So we can write limit h tends to 0 f of h is 2 power h plus 2 power minus h into tan h into root of tan inverse of h square minus h plus 1 upon 7h square plus 3h plus 1 whole power 3 minus f of 0. So we have f of 0 means tan 0 is 0, 0 into anything is 0. So we can write f of 0 is 0 whole divided by h minus 0, that is h. So we can also write it as limit h tends to 0, 2 power h plus 2 power minus h into tan h upon h into root of tan inverse of h square minus h plus 1 into 1 upon 7h square plus 3h plus 1 whole power 3. And we know that limit h tends to 0, tan h upon h value is 1. And the remaining you can substitute the limit. So I can write here f dash of 0 is equal to 2 power h plus 2 power minus h when limit h tends to 0, or we can also write limit h tends to 0, tan h upon h into limit h tends to 0, 2 power h plus 2 power minus h upon 7h square plus 3h plus 1 whole to the power of 3 into tan inverse of root of tan inverse of h square minus h plus 1. So we got tan h, limit h tends to 0, tan h upon h value is 1. And here we can substitute 2 to the power of 0 plus 2 to the power of minus 0 upon 7h square 0 plus 3h 0 plus 1 whole to the power of 3 into root of tan inverse of 0 minus 0 plus 1, which is equal to 2 power 0 is 1. So 1 plus 1 here we can add 2 upon 1 cube is 1 into root of tan inverse of 0 plus 1 is 1. So 2 times tan inverse of 1 is pi by 4. So we can add 2 into root pi divided by square root of 4 is 2. So we can give the answer as root pi. So we can go with an option B, root pi. If z is equal to 1 upon 2 minus 2i and such that mod of z plus 1 is equal to alpha z plus beta times of 1 plus I, where I is equal to root of minus 1 and alpha and beta are the real numbers, then what is the value of sum alpha plus beta? So substitute z is equal to 1 by 2 minus 2i plus 1, which is equal to alpha z plus beta. We can write alpha times 1 by 2 minus 2i plus beta times of 1 plus I, or we can write beta plus beta I. And here 1 by 2 plus 1 is, that is 3 by 2 minus 2i mod is equal to alpha upon 2 plus beta, plus we can write beta minus 2 times 2 alpha of I. And we know that mod z is equal to, if z is equal to x plus iy, we have root of x square plus y square. So mod of 3 by 2 minus 2i, we can write it as under root of 3 by 2 whole square plus minus 2 whole square, which is equal to alpha upon 2 plus beta plus I times of beta minus 2 alpha, and root of 9 upon 4 plus 4, which is a constant, and the other side we can write there is no real value, so we can add 0i, which is equal to alpha upon 2 plus beta plus I times of beta minus 2 alpha. And comparing both the sides, we can say beta minus 2 alpha is equal to 0, beta minus 2 alpha is equal to 0, and alpha upon 2 plus beta is equal to under root of 9 upon 4 plus 4, that is 16. sorry, 4 4 is a 16 plus 9, 25 upon 4, which is equal to 5 by 2. And from here beta is equal to 2 alpha. So let us substitute beta is equal to 2 alpha here. Alpha upon 2 plus 2 alpha is equal to 5 by 2, or we can write alpha plus 4 alpha is equal to 5 upon 2. So 5 alpha is equal to 5. So alpha is equal to 1. When alpha is equal to 1, substituting here back, beta is equal to 2 times of alpha, that is 1. So 2. So alpha is equal to 1 and beta is equal to 2. So 1 plus 2 is 3. So the sum alpha plus beta is 1 plus 2, which is equal to 3. So option 1. Let O be the origin and the position vectors of A and B are given 2i plus 2j plus k and 2i plus 4j plus 4k respectively. And if the internal bisector of angle AOB meets the line AB at C, then the length of OC is. So here given position vector of A, OA is equal to 2i plus 2j plus k, and the OB vector is equal to 2i cap plus 4j cap plus 4k cap, and if the internal bisector of angle AOB, say this is A, O and B, and the internal bisector of AOB meets AB at the point C, then the length of OC is, since it is a bisector and we know that from the bisector theorem, OA upon OB is equal to AC upon CB or BC. So we can say that AC and BC vector divides in the ratio OA is to OB. So what is the length of OA? The vector magnitude of the vector OA is equal to root of 2 square plus 2 square plus 1 square, which is equal to root of 4 plus 4 8 8 plus 1 9, which is 3 units. And the length of vector B OB is equal to root of 2 square plus 4 square plus 4 square, which is equal to root of 16 plus 16 32, 32 plus 4 is 36, which is equal to 6. So we can say that AC is to CB, that is AC by CB is equal to, or the length of AC and CB, which is equal to OA upon OB, which is equal to 3 upon 6, say 1 by 2. So the point C OC vector, we can write it as, so here it is one part and two parts. So we can write the vector C, position vector of the C as 1 times of OB vector plus 2 times of OA vector divided by 1 plus 2. By using the section formula, we can write this. So which is equal to 1 times of OB vector, that is 2i plus 4j plus 4k plus 2 times of OA, that is 4i plus 4j plus 2k divided by 3, which is equal to 2 plus 4, that is 6i, 4j plus 4j, that is 8 times j, plus 4k plus 2k, that is 6k upon 3. And the length of OC vector we can write, the length of OC vector is equal to 1 upon 3 times, and even we can cancel here, we can take out the 2 common, 2 by 3 times of the length of 3i plus 4j plus 3k, that is 2 by 3 times under root of 9 plus 16 plus 9, that is 25 plus 9 34. So 2 upon 3 root 34. So 2 by 3 root 34, which is option D. In a triangle ABC, y is equal to x is the bisector. So let us consider This is the line equation. Y is equal to x is the bisector of angle B, and the equation of the side AC is given. Equation of side AC is 2x minus y minus 2 is equal to 0, and 2 times of AB is equal to BC, that is AB upon BC is equal to 1 upon 2, and the points A and B are respectively, A is the point 4 comma 6 and B is the point alpha comma beta. Then what is the sum? Alpha plus 2 beta. Since the line y is equal to x is the bisector, so we can say that since point B is lying, point B alpha comma beta lies on the line y is equal to x, which implies that alpha is equal to beta. This is the one condition. And the next one, and since y is equal to x and the point of intersection of AC and, let us consider this is M, BM. The line equations AC and BM are intersecting. So put y is equal to x in the line AC equation, that is 2x minus x minus 2 is equal to 0. That is x minus 2 is equal to 0. So we can write x is equal to 2. So when x is equal to 2, we can also say that y is equal to 2. So the point M we can mark it as 2 comma 2. So this point M is 2 comma 2. And now since we know the point A and point M, we can find the point C by using the section formula. And since we know that AB upon BC is equal to, since angle B is a bisector, we can write AM upon MC. And we can say AB upon BC is equal to 1 by 2. So AM upon MC is equal to 1 upon 2. So here one part and two parts. So point M is dividing A and C internally in the ratio 1:2. So A is the point 4 comma 6 and M is the point 2 comma 2 and C is the point, let us consider to be some P comma Q. So we can use the formula, section formula, 1 times of P plus 2 times of 4 upon 1 plus 2 3, and again 1 times of Q plus 2 times of 6 upon 1 plus 2 3, which is equal to 2 comma 2. Substituting and equating, we'll get P plus 8 is equal to 6 and Q plus 12 is equal to 6. So we got P is equal to minus 2 and Q is equal to 6 minus 12 is minus 6. So we got the point C as minus 2 comma minus 6. So we got vertex C minus 2 comma minus 6. Minus 2 minus 6, and A is the point 4 comma 6 and B is the point alpha comma alpha, and since y is equal to x is the bisector, so we can say that the image of this point C, image of this point with respect to the line y is equal to x will be lying on the side AB. So we can say that the image with respect to y is equal to x, we can write x coordinate and y coordinates will interchange. So minus 6 comma minus 2 is the point which is on the side AB. So let us consider this as C dash. Now slope of AC is equal to 6 minus of minus 2 upon 4 minus of minus 6, that is 8 upon 10 or 4 upon 5, and slope of AB can be taken as 6 minus alpha upon 4 minus alpha, which is same as 4 upon 5. So 6 minus alpha upon 4 minus alpha is equal to 4 by 5. On simplifying, we can write 30 minus 5 times alpha is equal to 16 minus 4 alpha. So we can write 30 minus 16 is 14 is equal to 5 alpha minus 4 alpha is 1 alpha. So alpha is equal to 14. Since alpha and beta both are same, so beta is also equals to 14. And hence we can say alpha plus 2 times beta is equal to 14 plus 2 times of 14, that is 3 times of 14, which is equal to 30 plus 12, 42. So option D is the answer. In an arithmetic progression, the sixth term is 2 and the product A1, A4, A5 is the greatest one. And let A be the first term and D is the common difference of arithmetic progression AP. So that we can write A6 as A plus 5D is equal to 2. So we can write A is equal to 2 minus 5D. And now consider the product A1 into A4 into A5, which is equal to A into A plus 3D into A plus 4D. So A we can write it as 2 minus 5D into A plus 3D as 2 minus 5D plus 3D into 2 minus 5D plus 4D, that is 2 minus 5D into 2 minus 2D into 2 minus D. So here we got the function in terms of D. Let us consider f of D. And to get the product is greatest one, so let us use the concept of applications or derivatives. So to get maximum value, we need to consider f dash of D is equal to 0. So let us differentiate f dash of D is equal to, so 2 minus 5D into 2 minus 2D into differentiating of 2 minus D is minus 1 and again plus. Now consider the second term 2 minus 5D into the last term 2 minus D into differentiating the second term, so we'll get minus 2 plus again differentiating the first term, remaining the two terms as it is 2 minus 2D into 2 minus D into differentiating 2 minus 5D is minus 5. So on simplification f dash of D is equal to, so minus 1 times of, so 4 minus 10D minus 4D plus 10D square and again minus 1 times of, or minus 2 times of 4 minus 10D minus 2D plus 5D square and again minus 5 times of 4 minus 4D minus 2D plus 2D square. So we can write f dash of D is equal to minus 4 minus 10 minus 4 is minus 14, so plus 14D and here it comes minus 10D square and here it comes minus 8, minus 10 minus 2 is minus 12, so plus 12 2s are 24D and again minus into plus minus 10D square and again here minus 20 minus 4 minus 2 is minus 6, so it comes plus 30D and again minus 10D square. So after simplifying you will get f dash of D is equal to minus 30D square plus 68 times D minus 32, or we can write minus 2 taken common 15D square minus 34D plus 16 and factorizing here 15 into 16 we can write 3 into 5 into 2 into 8, 8 3s are 24 minus 24 plus 10 is 34, so we can write 15D square minus 24d minus 10d plus 16. So from the first two terms we can take 3 common, 3d common. So we can write 5d minus 8, and the second two terms we can take 2 common, 5d minus 8. So we can write 5d minus 8 into 3d minus 2. So we can write f dash of d is equal to minus 2 times of 3d minus 2 into 5d minus 8. So the critical points are here. D is equal to 2 upon 3 and d is equal to 8 upon 5. So by using the wavy curve, so 2 upon 3 and another point 8 upon 5. So based on the sign change rule, so it's positive, but because there is a coefficient negative minus 2, so we need to consider here the curve as, so here it in this region negative, and here it is positive, and here it is negative. So we can say that at the point 2 upon 3, the sign is changing from negative to positive, so which is a minima, and at the point 8 by 5, the sign is changing from positive to negative. So at d is equal to 8 by 5, the sign changes from positive to negative, which implies that f of d have f of t is maximum, the function is maximum at d is equal to 8 by 5. So we can say that the product to be greatest one, so d is equal to 8 by 5 to be considered. So we can go with an option A.